Can we draw the correct straight line on a graph if you know the slope and some point? Well, the answer is definitely yes. And this is what the point slope form relies on. It doesn't rely on the y-intercept, but any point. Okay, and we can say in this case, any point. So I know that the slope is 3 over 4, and I know the line passes through the coordinate 8, -1. Well, if I were to draw that 8 over -1, slope of 3 over 4, yeah, I can draw the correct line. Okay, there's a unique line that goes through there, though, that point with that slope. I can find the y equals mx plus b, or so I can find the point slope form of the equation. 3 over 4, okay, x minus blank plus, okay, and all I do is then I plug in my coordinate that was given to me. X is 8, y is -1. And there it is, there's my equation. Now I can use this equation to calculate coordinates, but I could also just fill out this table of value using slopes. Okay, down 3 over 4. Okay, that's going to be down 3 over 4. Okay, I can do, over 4 up 3. Okay, so up 3 from there is going to be plus 2, plus 12, and we can fill out the table of values, and we can just double check, does this table of values fit into this equation? Well, 12 minus 8 is 4, 4 times 3 divided by 4 is 3, 3 minus 1 is 2, yeah, that gives me the right coordinate. Okay, so this is my point slope form. I could fill out the table of values with my point slope form very easily by starting with my starting point, using my slope. I can come up with my point slope equation. I can see the progression on a graph. And remember that these three things are always connected. So we can find the equation of the line knowing the point, only the slope and a point, we can plug into the point slope form of the equation. And just a reminder, the way I've done it here is a little bit different than what you might see. Usually I like to put the y on the dependent variable y on one side of the equation. Many of the formulas will just show y minus y1 and then the slope times x minus x1. Okay, so these are equivalent. This I think is a little bit more useful because it's a y equals equation. And just a reminder that the table, the graph, and the equation are all interrelated. So if we can work out the table, there's a way we can work out the pattern on the graph and the pattern, the equation of the relationship. So here we have a word relationship. The cost of ship mangoes to Vancouver is related to the number of mangoes. So the number of mangoes is my input. My cost is my output. Okay, so my cost is my output. I'm going to make a table of values here. So I have 300 mangoes and the cost is $325. 1,200 mangoes costs $1,045. I want to find the equation of this relationship, and I'm going to do it with my table, because on my table I can see my changes in y and changes in x. That means I can see my slope on the outside of the table like this. So my change in y, okay, so 1045 minus 325 is $720. 1,200 minus 300 is 900 mangoes. So then to get the slope is a change in y over the change in x. So $720 divided by 900 mangoes gives me 80 cents per mango. I want to write the equation of the cost. So my cost y is equal to my slope, 0.8 times x minus x1 plus y1. So I want to be able to plug in any x and y pair into this equation. So I'm just going to choose 300 mangoes and $325. And there it is. There is my point slope form of the equation. And this relates to costs of mangoes. Costs as a function of mangoes is equal to 0.8 mangoes minus 300 plus $325.